All right, everybody. Those of my students that were there for my chemistry course, they probably already know, but for the new ones, I just want to add that we are starting our classes for A level soon and June onwards. If anybody's interested, please go ahead and do talk to the admin, get whatever information you need. Our classes, our slots basically are very, very limited. Okay. What are we going to be covering over in this particular session? So we're going to look over some topics that I think, at least in my experience, students struggle with quite a lot. So one of them, of course, is electricity. That's where we're going to start with. So electricity, I have written it down as electricity, but we're going to be going over everything. So we're going to be going over your electrical circuits. We're going to be going over your current, voltage, all of that. And then, of course, another major component of this is your topic of electromagnetism, right? Your motor principle, your generator principle, and questions on these can be tricky as well. So we will be taking a look at that. Then we will follow it up with a bit of waves. So we will discuss regarding your basic definition of waves, and then some trickier concepts like total internal reflection, like your refraction, diffraction, all of that. For thermophysics, we will take a look at a bit regarding your heat capacity, regarding Boyle's law, Charles' law. And if we have time, then towards the end, we might take a look at some, you can say, general physics. If we have time, we will take a look at some general physics, turning effect of moment, all of that. But we will be starting off with electricity and waves are the two major things that I basically want to cover over here with you guys. And in electricity, I'll try my best to concentrate on electromagnetic induction. Starting off, let's take a look at our electricity first. So in electricity, when you guys are studying, right, you guys can divide up the topic into three portions. Okay. Either you guys can go ahead and talk about your electrical quantities. So electrical quantities are your current, voltage, power, efficiency, all of that. Then you have the circuits themselves. And then you have electromagnetism. So when you're studying, try to study it down like that. And meanwhile, if you guys have any questions, anything that's not making sense, anything that you guys want me to ask, please type it out in the chat. Okay. So, okay, let's go over our electrical quantities. So in electrical quantities, you guys should know about the definitions and formula for each of them. I have listed them down. Okay, so you guys, when you're revising it, for example, this is what you guys want to concentrate on. That each of these electrical quantities, you have learned not only their definition, but you have also learned their formulas, right? And for every quantity, there are multiple formulas. So you might want to make sure you guys want to concentrate that you have those formulas down. The students who are doing Edexcel board, you guys get a formula sheet, which does make this much easier for you. But students doing Cambridge board, formula sheets are not given, right? So you will have to learn out these formulas. So let's go ahead and take a look at each of these quantities one by one. So let's start by talking about your charge. Okay. So electrical charge, what actually is electrical charge? I mean, I'm sure you guys have, encountered it a lot in physics, but what actually is it, right? Like when we talk about it, what is it really? So electrical charge is actually a property of any material that causes it to experience a force when placed in an electromagnetic field. That is the definition of it that you guys will see given quite commonly. What this actually means is this, is if I take any material and I place it in an electromagnetic field. Okay, so I place it in any magnetic field. And that object, that material experiences a force. I place it in the field and that material experiences a force. That is because the material has a charge on it. Okay. So if I take any charge and I put any charge, take an electron, put it in a electromagnetic field, that electron will experience a force, right? That is because of the fact that it has a electrical charge. So that's what a charge is. Charge, as you guys know, the unit is coulombs. Please make sure you guys know your units really, really well for all these electrical quantities. Again, emphasis on the Cambridge students that are doing their exams. You guys, your paper 4 is now done, okay? But your paper 6 and paper 2 is still left. So please keep in mind that you will often have to figure out the unit yourself, okay? Not provided, you guys will have to provide the unit yourself. So keep that in mind. The formula that you guys can use to find the charge is Q is equals to NE, where N is, of course, your number of electrons, and E is the charge of one electron. This formula you will not use quite commonly. It's not a formula that you will use commonly throughout your paper. Like I have not seen it that frequently, but it does come once in a while. So it's a good formula to have in your handbook. Okay. So N is actually the number of particles or number of electrons. So if you have like one piece of metal, how many electrons does it have? Right? And E stands for the charge of one electron. So the charge of one electron has a fixed value. It is 1.6 into 10 raised to the power of negative 90. Okay. This value will be given to you guys in your question paper where the data is given. So both for Cambridge and Edexcel students, you guys have a data sheet with the paper, right? Where all the constants and the factors and all of these values are written. So please remember to consult it. Secondly, we have current. So current is simply what is to understand what current is. Okay. Let's take a look at the picture. This is the picture. Okay. What exactly is current? What exactly is voltage? I'll explain both of these things. In fact, I'll explain what is resistance. I'll explain everything just by using this one diagram. Okay. So what simply happens is this, that when you take a piece of metal, because as we know, metals are good conductor of electricity. When you take a piece of metal and you connect it to a power supply, what happens? One end of the metal or one end of the wire is connected to the negative terminal of the battery. The second end of the wire is connected to the positive terminal of the battery. Now, what will happen that the electrons in the wire are repelled from the negative terminal of the battery and they are attracted towards the positive terminal of the battery. This causes the electrons to start flowing from the negative terminal towards the positive terminal. How fast these electrons will flow, that is current. Okay, so current is rate of flow of electrons. Rate means rate is often a word that you guys can simplify in terms of speed. Okay, how fast are those electrons moving? That is current. Greater the current, the faster the electrons are moving. Slower the current, the slower the electrons are moving. So current is rate of transfer of electrons or rate of flow of electrons. Current is of course measured in amperes. And now I will introduce the first formula for current. Please keep in mind that for every single quantities, there are multiple formulas. So your first formula related to current is this. Current is equals to charge All right, sorry guys, there seemed to be some issue with my laptop. Okay, so now let's move on to what voltage is, right? Again, we can understand voltage by looking back to the diagram that we were discussing earlier. So voltage is quite simply put, defined as energy per unit charge. Okay, energy per unit charge. Now, you guys, when we talk about energy, where is the energy coming from? The energy is coming from the power supply, right? The power supply is providing energy to the electrons, causing the electrons to travel from the negative terminal of the battery to the positive terminal of the battery. So electrons are traveling from the negative terminal of the battery to the positive terminal of battery because there's some kind of energy that is leading to it. And that energy is coming from what? The power supply. Right? So when I take my piece of wire and connect it to a negative terminal and positive terminal of the battery, it causes or it provides energy to the electrons. And those electrons move from negative terminal towards the positive terminal. That energy is voltage. Okay. So how much energy for 1 coulomb charge? For 1 coulomb of charge, how much energy is the battery providing? That is voltage, right? So voltage is defined as energy transferred per unit time. Please keep in mind that for energy, we can also use work done. So you can either define it as energy transferred per unit time or energy transferred per unit charge or work done per unit charge. I'm going to tell you guys something really important. Please remember this. Energy is equal to work done. Always. When you're solving your questions on, your work done, power, forces, energy, right? Please keep in mind that if the examiners ask you to find the energy, you can also get the answer by finding the work done. Or if they ask you to find the work done, you can get the answer by finding the energy. So energy and work done are equal to each other. So in this case, the voltage is either energy per unit charge or work done per unit charge. It's the same thing. Voltage is measured in volts, and this is the formula for voltage. Energy per unit charge or work done per unit charge. This is the first formula of voltage that we are doing. There's one formula for current that we have covered and one for voltage. Like I said, keep in mind that there are multiple formulas for all these quantities. That's voltage. So let's take a look at the third quantity, which is resistance. Now, what exactly is resistance? If you open up your Google, you open up your textbooks, you guys are going to see statements like resistance is the opposition to current or resistance is the opposition to flow of electrons. But what actually is it, right? I mean, we understand what current is. The electrons are flowing and the rate of flow of electrons is current. Fine. We understand what voltage is. Voltage is the amount of energy we're giving the electrons per unit charge. But what is resistance? Opposition to flow of current. What opposition? So to understand this, go over the structure of metals. Students who are doing chemistry will find this, can relate this to their chemistry knowledge as well. What is a metal made up of? A metal is made up of positive ions surrounded by a sea of delocalized electrons. Right? That's it. That's what a metal is. Now, what happens? What happens is this, that when these electrons start flowing from negative terminal of the battery to the positive terminal of the battery, what happens? These electrons will collide with each other, right? Like, I mean, think about it. The electrons are moving from one end to the other. They will obviously not be moving in a straight line, right? They're electrons, so they're all traveling towards the same side. They're all going towards the positive terminal, but they will be bumping into each other. They will be colliding into each other. And every time the electrons will bump into each other, every time the electrons will collide with each other, they will lose some energy and that causes them to slow down. And that is resistance. Okay, so the resistance is basically just the electrons bumping into each other, just the electrons colliding with each other, and in the process, they lose energy and they slow down. Okay, so that is how, when they say it's opposition to flow of currents, that's how the opposition is happening. The electrons are losing energy by colliding and bumping into each other, right? So that is what resistance is. So resistance, remember this, that voltage and resistance are directly proportional to each other. Okay, so in your exam questions, right, sometimes they will give you like a circuit and they will say, oh, the resistance is increased or the resistance is decreased. What will happen to the voltage? What will happen to the potential difference? So remember this, okay, that if the resistance is increasing, the voltage will also increase, right? So if the resistance, my electrons are slowing down, if they're colliding with each other, they're slowing down. So I need to provide more energy, okay? And resistance and current are inversely proportional, okay? Resistance and current are inversely proportional. Meaning what? Meaning that if the resistance is high, the current will be less. Why? The reason for that is because if the resistance is high, that means the electrons are colliding with each other quite a lot. They're slowing down. So obviously the current will be low. Why? Because current is flow of electrons. So if the electrons are colliding with each other, they're slowing down. So they're not really flowing, are they? So if the examiners give you a circuit, right? And both Cambridge and Edexcel students probably have seen questions on this quite a lot. So what you will actually see is that if the examiners say we have increased the resistance, what will happen to the voltage? Please remember the voltage will also increase. Since the resistance is now higher, I have to give more energy. But if they ask you what will happen to the current will decrease. Why? Because more resistance means that the electrons will be slowing down. So the flow of currents is now lesser. And this actually brings us to what is our basis of Ohm's law. Ohm's law states that current and voltage will be directly proportional to each other if resistance is constant. Okay? So if resistance is constant, meaning that resistance is not changing, voltage and current will be directly proportional. But if resistance is changing, then this is what you guys will remember. All right, that if resistance is increasing or decreasing, voltage will increase and decrease. But if resistance is increasing, current will decrease. Okay, so current and resistance are opposite. Voltage and resistance are directly proportional. But when we talk about Ohm's law, so in Ohm's law, we are assuming that resistance is not changing. So voltage and current are directly proportional to each other. And if you make a graph, so in the graph, you will get a straight line going through the origin. Now, when we talk about resistors, right, you have either fixed resistors or you have variable resistors. In your syllabus, there are 4 variable resistors that everybody should know about. A bulb, a diode, a thermistor, and a light-dependent resistor. For every single one of these graphs, every single one of these resistors, you guys should be able to draw the graph and you guys should be able to explain the basic principle behind it. Okay? Should be able to do both. Explain the graph or draw the graph and explain the basic principle behind it. So for example, let's take a look at our filament lamp. This one is filament lamp. Okay. For a filament lamp, you guys can see that we do not get a straight line. Instead, we are getting a curve. Why do we get a curve? I will tell you guys the answer. In fact, let's do one thing. Let's write down the answer so everybody can see it. So for a filament lamp, what happens? For a filament lamp, what basically happens is this, that as the voltage increases, the current also increases. Now remember one thing, that current is always related to heat loss. Always, 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 always. If the current is high, the heat loss will be high. Remember that. Okay? If the current is going to be high, the heat loss is going to be high. Wherever there is high current, there is heat energy. They go hand in hand, right? So the current increases, right? When the current increases, this causes the temperature to rise. When the temperature rises, what happens? The electrons gain kinetic energy and they flow faster. They gain kinetic energy and they move faster. Now, if the electrons are moving faster, what are we going to see? Hence, there will be more collisions. If there are more collisions, what is going to happen? They will lose energy and they will slow down. Hence, resistance increases and current decreases. Okay, so this is what happens in a filament lamp. This is why a filament lamp is going to give you a curve. The reason the filament lamp is giving you a curve is because the filament lamp gets hotter and hotter and hotter as the current rises. This causes the temperature to increase. And this causes the electrons to move faster. And this causes more collisions. And that increases the resistance. So that's why we don't get a straight line, we get a curve. Because initially the resistance might be constant, but later on, when the current is high, right? If you look at the diagram over here, when the current is high, the resistance increases. Okay. As a result, you guys can see that the current starts to decrease. If you look at the graph, look, the gradient is decreasing. So the current starts to decrease. Okay. So when the voltage is high, the resistance also becomes high. So the current decreases. So filament lamp acts like a variable resistor. Okay. The resistance is not constant. It changes. When the voltage becomes high, the resistance also ends up changing. It increases. So that's our filament lamp. The second thing you have is your diode. Okay. For a diode, it's really easy to understand, right? A diode only allows the electrical current to pass in one direction. That's it. Okay. So when we talk about our electrical current, everybody over here should know, you guys should know that we can have direct current and we can have alternating current. Can anybody please type out in the chat what do you guys think is the difference between direct current and alternating current? Right. Okay. Anyway, any more answers? Would anybody else like to give their answer? Right. You are all correct, right? Direct current only travels in one direction. So alternating current travels in both directions. So to understand this, you guys have to realize that your current is a vector quantity. Remember that current is a vector quantity. Okay. So it can either be in one direction or it can fluctuate. It can change directions as well. So diode, basically what it does is that it makes sure that the current will only travel in one direction. Okay. So for example, if you connect the circuit like this, okay, this is our positive and this is my negative terminal of the battery. Okay. And this is my diode. So it will only allow the current to travel in one way. That's it. Okay. It will not allow the current to travel in the opposite direction. So for example, if I change this up, I put the negative positive over here and negative over here. So now it will not allow the current to pass through basically. Okay. So that's what a diode does. Then you have a thermistor and an LDR. Okay. The graph for thermistor and LDR are both similar. A thermistor helps in sensing changes in temperature. Okay. So thermistor helps in what? Sensing change in temperature. So thermistor responds to changes in temperature. In a thermistor, as the temperature increases, the resistance decreases. And as the temperature decreases, the resistance increases. Now keep in mind that this is different than what happens normally. If you remember in a filament lamp, I told you guys that as the temperature increases, the resistance increases. Now you might look at me at the same time and be, probably wondering that, Miss, literally on the same screen, you have written two opposite things. On the same screen, you have written that as temperature increases, the resistance increases, and now you're writing down something different. So keep in mind that for a filament lamp, this is what normally happens, okay? Normally, when temperature increases, the resistance increases. But a thermistor is different, okay? Why? Because a thermistor is not made up of metal. It's usually made up of a different material that we call a semiconductor. So a thermistor is basically different. It's an exception because it's made up of a different material, so it responds in a different way. Okay. Generally speaking, as the temperature increases, um the resistance increases. That's the general rule you guys can always go with. Okay. This is specifically only for a thermistor. Only thermistor behaves in this way, and that's because it's made up from a completely different materials. When you guys are going to do your A levels, you guys are going to study about this in a lot more detail. Now, along with your graphs, you guys should know about resistivity. When you talk about resistivity, especially students who are doing Cambridge board, you guys should know about what resistivity is, all right? So resistivity is a property of the material. Remember that. Just like so, yeah, students who are doing their Cambridge board, okay, Edexcel and Oxford do not have to worry about this. Students who are doing Cambridge board, please make sure that you guys go over this formula for resistivity, okay? Then we have power. Now for power, The definition is the same that you guys have been studying throughout, right? Like throughout, probably from grade 9, grade 8, you guys have been studying that power is energy per unit time. Okay. So the definition in electricity is the same, but the formulas are different. So please, please, please learn these formulas. There are three formulas for power related to the topic of electricity. Power is equals to VI. Okay. Power is equals to voltage into current. Formula number one. Formula number two, power is equals to I square R. Formula number three, power is equals to V square upon R. Okay. So in the topic of electricity, there are three formulas of power that you guys should know. Power is equals to VI, power is equals to I square R, and power is equals to V square upon R. You might be wondering, Miss, why do we have to learn all these formulas? The reason why is because sometimes in the exams, they will not give you all the information. So for example, they'll only give you the current and the resistance, right? So you guys can go through the long calculations. You guys can, calculate the voltage and then go through it, or you guys can just learn these formulas. So if they've only given you current and resistance, you directly apply the formula, get your answer, get your marks, move on to the next question. Okay. So for power, there are three formulas. Do learn all three. Then when we talk about efficiency, so efficiency is, I believe everybody over here probably does have a good idea about efficiency. So efficiency is useful output divided by total input. Okay, whatever our useful output is, right? So for example, we have a bulb. So with a bulb, the total input is obviously, what is our input? Electrical energy, right? Now from that electrical energy, our useful output is light energy. That bulb will produce light energy. It will produce heat energy, but that heat energy is not what we want, right? That's not what our desired output is. We want a bulb to give us light. We don't care about a bulb producing heat energy. So the useful output for us is light. Heat energy is just wasted energy, right? So you take your useful output and you divide it by whatever your total input is. Okay, Rehan, I will go over the Sankey diagram towards the end when we have a bit of time. Okay. So that was related to your electrical quantities. The second thing you guys need to go over is your electrical circuits. Okay. Now, in electrical circuits, please practice solving your electrical circuits. As many questions as you guys can, because these can at times be tricky. So we can have either series circuits or we can have what is known as a parallel circuit. Can somebody please, can somebody over here tell me what are the advantages and disadvantages of series and parallel circuits? Does anybody know? Could somebody please type it out in the chat? What are the advantages and disadvantages of series circuits and parallel circuits? Yes, okay. Anyone else? Would anybody else like to give their answer? Okay. Mm-hmm. Yes. All right. So I've got some good answers over here from you guys. You guys are correct. So when we talk about a series circuit, okay, in a series circuit, obviously, because you are so in a series circuit, all the resistors are connected in a line. The resistors, basically, when we talk about the current, right? The current has only one path to go from. That's it. That's what a series circuit is. The current has only one pathway to travel. So for example, if the current wants to get to resistor 2, it can only do that by going through resistor 3 or resistor 1, right? If the current wants to go through resistor 1, it has to go through the other resistors as well. So the current has only one place to travel from. But the problem with the series circuit is, quite frankly, that if one of the um, electrical component gets damaged, the entire circuit is useless, right? Because the current only has one pathway to follow. So it can't get to, for example, if the current has to go through R2, so if R1 is damaged, that's it. It can't go anywhere else. It can't get to R2 no matter what. In a parallel circuit, the current has multiple pathways to opt from. Okay, so the current can go to R1 and R2 and R3. It has uh, it has its own pathway, right? The current has multiple pathways through which it can travel from. So even if one of the components is damaged, all the other components will still be able to function normally. In a series circuit, current remains the same. Okay, in a series circuit, current remains the same. Why does the current remain the same? Because the current only has one pathway to follow, right? The current can only take one path, it can only take one route. So where is it going to go? It's not going to go anywhere. The electrons can only go through one pathway, right? Since the electrons can only go through one pathway, so the current in a series circuit remains the same. In a parallel circuit, current gets divided. Why? Because now some of the electrons might go to R1, some of the electrons might go to R2, some of the electrons might go to R3. Okay? But in a series circuit, the electrons can only go in one pathway. That's it. So in a parallel circuit, current is divided. In a series circuit, current remains the same. In a parallel circuit, the voltage remains the same. Okay, so the amount of energy going to each resistor is the same. But in a series circuit, the energy is divided. So some of the energy goes to R1, some of it goes to R2, some of it goes to R3. Okay, but in a parallel circuit, all of them will get the same energy. Now, let's talk about electromagnetic induction. Okay, in electromagnetic induction, three things you guys should basically go over: motor principle, generator principle, and transformers. Okay, so for your motor principle, okay, what is the motor principle? Let's first understand this. So when you talk about your motor principle, if you have a current carrying wire, so current carrying wire means that if you guys have a wire that is connected to a power supply, okay? If you have a wire that is connected to a power supply. So if you have a current carrying wire, you guys have a piece of wire, you have connected it to a power supply, okay? And you place it in a magnetic field. The wire will experience a force, okay? That's what a motor effect is. If you have a current carrying wire, you take any wire that has electrical current in it and you put it in any magnetic field, the wire will experience a force. Examiners will ask you why. And what are you guys going to say? You guys are going to say, well, we were told the answer. We'll just write down the answer exactly. What is the answer? The current carrying wire produces its own magnetic field. Okay, remember this. Any wire that has electrical current in it, it produces its own magnetic field. Okay, the wire produces its own magnetic field. So the magnetic field of the wire and the magnetic field of the magnet. There are two magnetic fields. One is the magnetic field of the wire and one is the magnetic field of the magnet. They interact. They both interact with each other. And hence, a force is exerted. This is your motor principle. Everybody learn this, especially Edexcel students, because I promise you, you will see this a lot in your past papers. Okay, so the wire produces its own magnetic field. The magnet has a magnetic field. They both interact with each other, and hence a force is produced on the wire. For the motor effect, we will be using Fleming's left hand rule. So everybody remember, we do have Fleming's rule. Okay. For Fleming's rule, we have the left hand rule and also we have the right hand rule. Using the correct hand is very important to get the correct answer. Okay. If you don't use the correct hand, you will, even if you do everything correctly, you will not get your correct answer. Okay. So for the motor, we always use the left hand. For the generator, we always use our right hand. Motor is left, generator is right. Okay. And the positioning of the hand is also very, very, very important. The thumb and the first finger make an L shape. Remember that. Okay. First finger and thumb need to make an L shape. The second finger is you will bend at 90 degrees. Okay. Second finger bends. The first finger is straight. And the thumb and the first finger need to make an L shape. Okay. And the second finger you will bend. I have seen students doing it the other way around. I have seen them bending the first finger and then opening the second finger. That's not correct. Right? You guys are going to get the wrong answer with that. So the thumb and the first finger make an L shape, second finger bends. Whether you're using the right hand rule or left hand rule, okay, the answer will be the same. The hand position will be the same. Now, the thumb basically points you in the direction of the force. Okay. The first finger points you in direction of your magnetic field. Right. So as we were discussing, the thumb points in direction of the force. The first finger will always point in direction of the magnetic field. And the second finger will point in direction of the current. Okay. So let's take a look at the diagram that's in front of us. Using Fleming's left hand rule, can you guys tell me what do you think should be the direction of the force on this particular wire? Type out your answers in the chat. What do you think? What should be the direction of the force acting on this wire if you follow the Fleming's left-hand rule? First finger points towards the magnetic field, second finger points towards the current. Right. So your force is going to be acting upwards. You guys are all correct. Right? The current is your second finger. You guys will open your hand exactly like this. The second finger is going to be in direction of the current. First finger is going to be towards the magnetic field. So this way. Second finger this way. So automatically your thumb will end up pointing up. So that's your motor rule, right? So what happens in a motor? In a motor, what basically happens is this, that on one side, you will experience a downward force, and on the other side, you experience an upward force. Okay? In a motor, what actually happens is that one side experiences an upward force, and the other side experiences a downward force. So this produces turning effect of moment. I don't know if you guys have ever related or put these two things together or not. But actually what happens is that because on one side you have a downward force and one side you have an upward force, right? So the force produces a turning effect of moment. Hence, the motor rotates. Okay. Now, what happens that, remember this, when the motor is, when the motor is completely horizontal, right? Uh, one side experiences upward force, one side experiences downward force. And as a result, the coil will rotate, right? As a result, because of turning effect of moment, the motor rotates. But when the coil will rotate, okay, and in this case, if you look into it, so you guys should be able to figure out if it's clockwise rotation or anti-clockwise rotation. So in this case, we will have anti-clockwise rotation, right? So what is going to happen, that your coil will rotate. After your coil will rotate, it will end up becoming completely vertical. Okay. Now, when the coil will become vertical, it will stop. Why will it stop? It will basically stop because your force and distance are no longer perpendicular to each other. I'm telling you this answer because this came recently in 2024 paper. Okay. So they asked specifically, this was a question, it was an Edexcel 2024 paper, that the coil becomes vertical and it stops. Why does it stop? So when the coil becomes vertical, it stops. Why? It becomes vertical, it stops because force and the distance are no longer perpendicular to each other. Because if you guys remember, for turning effect of moment, what is turning effect of moment? Force into perpendicular distance, right? So when it becomes vertical, right? When it becomes vertical, force and distance are no longer perpendicular to each other. So the coil will stop. But what will happen because of momentum? It will keep on rotating and it will become horizontal again. Okay, so the cycle keeps on repeating. Turning effective moment, the coil rotates and becomes vertical. When it becomes vertical, now the force and distance are no longer perpendicular, so it stops. But because there is momentum, right? So the coil again rotates and again becomes horizontal. And this will keep on happening. That's how a motor works. Then, following a motor, we have a generator that we have to talk about. Okay, so a generator follows the principle of electromagnetic induction. Okay, what is electromagnetic induction? For the electromagnetic induction, also please go ahead and learn the answer that you guys are going to give. Because if you learn this answer, like I give you the answer for the motor effect, just like that, you can learn the answer for the generator as well. Okay, so the good thing about these answers is that you guys can learn them and then just write them down as it is. So for the generator, what happens basically that first of all, difference between motor and generator. What do you guys think? Please type it out in the chat. What do you guys think is the difference between a motor and a generator? Yes, Anusha, actually your answer is quite good. What do you guys think? And does any what who else would like to answer? Mm-hmm. Yes, good. Okay. Right. So a motor actually uses electricity, and as a result, you get movement, right? That's what a motor does. It uses electricity, and as a result, you get movement. You see it move. On the other hand, a generator doesn't you don't provide the electrical supply, right? All you do is that you take your generator and you place it in a magnetic field and you rotate it. Okay, so in a motor, you provide the electricity and the motor rotates. In a generator, it is the opposite. In a generator, you rotate the generator, and as a result, electricity is made. Okay, that's the difference. So, when we talk about electricity, now you might wonder, Miss, but how? How is it that we can take a piece of wire, rotate it inside a magnetic field, and that's it, we get electricity? So this we can explain using the principle of electromagnetic induction. For the principle of electromagnetic induction, you guys can say quite simply when the examiners ask you, what will you say? You will say, when the wire is moved or rotated in the magnetic field, it cuts the magnetic field lines. And I am not joking with the term cut. The students sometimes think that, like this is just layman term. No, you guys can write it down as it is in the exam. You'll get marks, right? It literally cuts the magnetic field lines. This causes the magnetic field to change. That's what is important. That's why we have to move the wire. That's why we have to rotate it, because the magnetic field has to change. Okay, so either you can move the magnet or you can move the wire. Both will give you the same result. Okay, So it cuts the magnetic field lines. Hence, voltage is induced in the wire. Okay, this is the electromagnetic induction principle, that whenever a wire is rotated in the magnetic field, it cuts those field lines, right? The magnetic field lines, it cuts them. So when it cuts them, voltage is induced. So it when it cuts those magnetic field lines, right? So it produces a force on the electrons, and that's how you get the electricity. That's how you get the voltage. That's how you get the current. So that is the generator principle. For the generator, we use the Fleming's right-hand rule. Okay. The rule is the same. Just like I taught you for the motor, the rule is the same. Okay. There's no differences in the rule. The thumb is still in direction of the force. The first finger is still in direction of the magnetic field. Second finger is still in direction of the current. The only difference is that you will use the right hand instead of the left hand. That's it. That's the only difference. So you will use the right hand rule. Yes, Ariba, you need the right hand rule for Edexcel as well. So you need the right hand rule when you talk about a generator. So the rule is the same, but for the left hand rule, you will, for the motor, you use the left hand. For the generator, you use your right hand. So that is your generator effect. Then, after your generator effect, the last thing that you guys have in the topic of electromagnetism that you guys should go over is related to your transformer. Okay. For a transformer, this is important for both Edexcel students as well as Cambridge students. Okay. What exactly is a transformer? A transformer can be used to increase the voltage or decrease the voltage. Okay. Let me share a picture with you guys. Just give me 1 second. Yes, you will use the left hand rule in motor. Zainab, yes, we can use an insulated wire as well. An insulated wire is also going to give you electromagnetic induction. Yeah, for a generator, we don't use the left hand, we use the right hand. Okay. The left hand is for the motor, the right hand is for the generator. Right. This is the picture that I wanted to share with you guys. Okay. So I just told you guys that we need a transformer. The transformer helps increase the voltage or decrease the voltage. Right? That's what we use the transformer for. Now you might be looking at me, be wondering, Miss, why do we need to do that in the first place? So when your power stations generate electricity, okay, whether that's a nuclear power station, hydroelectric power station, whatever, when a power station generates electricity, they use a step up transformer. Okay. What does the step up transformer do? The step up transformer converts the low voltage into high voltage. Okay. Now, you might be wondering, but Miss, why? What's the need for this? Why bother with the conversion? I mean, it just seems like an extra step. The reason you do that is because when you increase the voltage, the current decreases. Okay? When you increase the voltage, the current decreases. Now, you might be wondering, but Miss, why does that happen? That happens because power remains the same. Right? Power is energy. Energy is always conserved. Power remains the same. And power is equals to voltage into current. This is the formula we just discussed. Right? So when the voltage increases, the current decreases because the total power cannot change. So, right, fine. So we use a step-up transformer to take low voltage to a high voltage. But fine. Well, what does that do? That changes the current and decreases the current. But why? Why do we want the current to be low? To prevent energy loss. Because the electricity has to travel from power stations to our residential areas. And for that to happen, it has to travel through really, really long electrical cables. And if the current is high, that current will get converted into heat energy and we will lose a lot of that energy. There will be a lot of energy wastage, right? So what we do is that we convert that low voltage into high voltage. And in the process, the current is reduced. Okay. So this prevents energy loss in the form of thermal energy. Now, okay, fine. So we understand that why do we need to increase the voltage? So that the current decreases, so that there is less energy loss. Fine, makes sense. Now, once the electricity reaches our houses, reaches our residential areas, we use a step down transformer. A step down transformer takes that high voltage and converts it back into low voltage. Again, they will ask you why. All right, so we can understand the first part that we want to save energy. All right, but then why change it back into low voltage? That is because high voltage is dangerous. Remember that. It's not the current that is dangerous, it's the voltage. Current is simply how fast those electrons are moving. Voltage is how much energy they have. Okay. So in electricity, it's the voltage that you need to look at. Voltage, high voltage is dangerous. High current is not dangerous. Okay. So because now the current is entering where? Our residential areas. Since it's adding since it's going into residential areas, so obviously we don't want high voltage to be there because high voltage can lead to what? High voltage can lead to a person, if they get an electrical shock, the greater the voltage, the worse it's going to be, the more dangerous it is. So we decrease the voltage back to low. Okay, so that's why we use a transformer. Now, again, for a transformer, the examiners will at time ask you now to explain how a transformer works. Okay. To understand how a transformer works, this is what our setup looks like. So we have an iron core, and around the iron core, we have two pieces of wires that we have wrapped around. One piece of wire is connected to the power supply, and the power supply will always be alternating current. Okay. So we take a piece of iron core, we wrap a piece of wire around it. This wire is connected to alternating current. The second wire will be connected to whatever our load is. So am I connecting it to a house? It will be connected to the house. Am I using it to light up a bulb? It will be used to light up the bulb, whatever. Okay. The piece of wire or the coil that is connected to the alternating current is known as the primary coil. And the one that is connected to our load. So our load being a generator, our load being a house, our load being a microwave, our load being a bulb, whatever. That is the secondary coil. The examiners will ask you the principle. How does a transformer work? So I will tell you the answer that you guys can once again go learn and just write it down over there in the exam. What is the principle behind it? The principle behind is this. The primary coil is attached to the alternating current supply. This causes or this produces a changing magnetic field. Okay, when the current in the primary coil, because remember this, current and magnetic field always go hand in hand. If there is a current, then there will be a magnetic field. So this produces a changing magnetic field. The magnetic field will spread to the secondary coil with the help of the iron core. Right? So this induces voltage in the secondary. This is what you guys are going to write down. Remember this, that in a step-up transformer, okay, in a step-up transformer, the primary coil has less number of turns and secondary coil has greater number of turns. Okay. So if you have a step-up transformer is the one that increases the voltage. So the primary coil, this one will have less turns and the secondary coil will have more turns. Okay. Greater the number of turns, greater the voltage. Remember that, plain and simple. Okay. And in a step-down transformer, it's the opposite. The primary coil has more turns and the secondary coil has less turns. There are two formulas that you guys need to know. Please go ahead and note them down. Okay. Voltage in secondary coil divided by voltage in primary coil is equal to the number of turns of secondary coil divided by number of turns of primary coil. Okay, so voltage in secondary divided by voltage in primary is equals to number of turns of secondary divided by number of turns of primary. Another formula that you will find useful is this one. Voltage in secondary coil multiplied by current in secondary coil is equals to voltage in primary coil multiplied by current in primary coil. So go ahead, learn these formulas, and it should make it much easier for you guys to solve your questions related to your transformers. So far related to our topic of electricity, does anybody have any questions? If you guys have any questions, please go ahead and type them out in the chat. Yes, Rehan, we have already gone over the motor part. All right, if there are no questions related to electricity, so we are going to go ahead and take a small 5-10 minute break over here. Okay, so we'll take a small 5-10 minute break, and then we will resume and we will take a look at our waves. Especially, we will take a look at total internal reflection and all of that. Yeah, Anusha, we have gone over that also. Remember when we did all of these graphs and everything, right? So we have already gone over the different types of resistor and our V is equals to IR and all of that. Okay. If you missed it, then you could just go over the recording again. Or if I have time towards the end of the session, I might go over it with you. Okay, so we're going to go ahead and we're going to take a small 10-minute break now. Okay, we'll take a 10-minute break and then we're going to resume and we'll take a look at our waves. All right, let's go ahead and resume with our session. Let's take a look at our waves. Can I please just get a thumbs up from everyone in the chat? Is everybody over here? Everybody back from the break? I hope you guys had something to drink, something to eat, freshen up a bit. All right, okay, so let's take a look at our topic of waves. Now, in waves, right, the main things that you guys have to actually do one more thing. Can you guys also send me what board everybody is doing? So I have an idea of what majority students are doing, which board. All right, so it seems like pretty much everyone is doing your Edexcel board. Okay, so perfect. That actually makes it easier because then I can tell you guys what is coming specifically in your board exams, right? So when we talk about our waves, so in waves, obviously there are basic definitions that you guys have to go over. But what you guys need to primarily concentrate on is this. Reflection, I'm sure everybody knows. Refraction, everybody should know about refraction, and total internal reflection. Okay, these are the three things that every student should have an idea about. That is really important when it comes to the topic of waves. So first thing is first, let's take a look at some basic definition, right? When we talk about some basic definitions, so when we talk about a wave, we take a look at a few things. We look at its amplitude, we look at its wavelength, we look at its frequency, and we look at its time period. You guys should be able to define each of these. Okay. So for example, amplitude. Amplitude, what is amplitude? Amplitude is the maximum distance uh, from the equilibrium position. Okay. What is the equilibrium position? The resting position. So the resting position is this. Okay. Where the wave would be if it was not moving. So wherever the wave would be when it's not moving, that's the resting position. So the maximum distance from that resting position, the maximum distance of the wave from its resting position or equilibrium position is referred to as our amplitude. Okay. Now, what is a wavelength? You guys can define wavelength as the distance between two consecutive points. Okay, so any two points that are next to each other, they are defined as what? They are defined as your wavelength. Now keep in mind that the points have to be the same. What does that mean? Let me explain that. I cannot take this point and this point, and I cannot take these 2 points and call this a wavelength, right? Why? So you might be wondering this, that you just said the distance between consecutive points. So these 2 points are consecutive. They're like literally right next to each other, miss. Why can't this be a wavelength? That's because if you look at the wave, so over here, the wave is traveling upwards, right? If you look at the wave, so you will see this point is traveling upwards. And this point is traveling downwards. So we will not consider this consecutive. Okay. Consecutive means the point has to be the same. So the point, if this point is traveling upwards, the next point that we will choose also has to be traveling upwards. So if I choose this point, then the next point will be over here. Okay. And the distance between these 2 points is what we will refer to as our wavelength. Okay. So the wavelength is the distance between two um, points, that consecutive points that are the same. So either they're both moving up or they're both moving down. An easy way to look at your easy way to look at it is that you could measure the distance between two crests or two troughs. Okay, so you go between two crests or you go between two troughs. Okay, but when you're defining it in the exam, do not define it like that. You will say distance between two consecutive points that are the same. Then we have frequency. Can somebody define what frequency is? What do you guys think? In the chat. Arusha, you can say it, but don't say it in the exam. If they ask you the definition, right, then say in the definition, you will write down what I told you. Distance between two consecutive points that are the same. But if you are doing just like measurements or you have been asked to label on the diagram or whatever, then you can do it. Okay, but just don't say it as a definition. Okay, so can somebody tell me what is frequency? How do we define frequency? Yes. So frequency is the number of waves per unit second. Correct. And what is time period? Yes, time period is time taken for one complete wave. So how long does it take for one complete wave to pass? That is referred to as your time period. And you guys have to remember the formula. What formula will you remember? Frequency is equals to 1 divided by time period, and V is equals to F lambda. Now, the topic of waves you guys can divide into two categories. Properties of light and properties of sound. Okay. For properties of sound, you guys should know about like your sonar or radar system. You guys should know about sound waves. And you guys should know about refraction and reflection of sound waves. Okay. I will go over that with you guys. But importantly, when we look at light waves, okay? So there are three things we have to go over: reflection, refraction, and we have to go over our total internal reflection. I'm going to go over for refraction. We will take a bit of time because students do find it slightly trickier. What is reflection? Reflection is when a wave hits any reflective surface and it bounces back. So when a wave hits any reflective surface and it bounces back, that is referred to as reflection. I do want to emphasize that reflection is a property of all waves. Whether they are light waves, whether they're water waves, whether they're sound waves, does not matter. If it's a wave, it will show you reflection. Okay? Now, whenever you are making your diagrams, please remember the first thing everyone will always do is draw a normal. Start there. You will start at the normal. Remember that. Okay? Whenever you're drawing any diagram in your exam questions, internal reflection, refraction, I don't care what you're drawing. You'll draw the normal first. If it's related to light waves, you guys will draw the normal first. The normal is always at 90 degrees to the surface. First thing you guys are going to do. Okay. Secondly, you have your angle of incidence and you have your angle of reflection. All angles that you measure will be between the ray, between the light and the normal. Do not make this mistake of calling this the angle of incidence. You will lose marks. Sometimes the examiners deliberately give you this angle, okay? Like they will deliberately give you this angle. And then they will say, oh, can you give me the angle of reflection or whatever the question may be. So you have to remember that this is the angle of incidence, not that one. This is the angle of incidence. This is the angle of incidence. This is not the angle of incidence. All angles should be measured from the normal. Okay? So you have to remember to do this. Then, so if you take this angle, you'll get the incorrect value. So angle of incidence is always equal to angle of reflection. So whatever the angle of incidence is, the angle of reflection will be the same. Right? Reflection is generally pretty easy to understand. It gets a bit complicated when we talk about refraction. Now, this is what I want to go over with you guys. What is refraction? In school, your teachers, or if you guys have opened up your, or if you guys have opened up your, if you guys have looked at your school textbooks, you will often see this sort of a diagram, or this example is like commonly given, right? The example that is commonly given is this, that you have this glass that's filled with water, and inside the glass of water, you place a pencil. So it looks like the pencil is bent, right? Like when you look at the pencil through the water, it looks like the pencil is bent. And your teacher, your textbook will say this is an example of refraction. But what is actually happening? What is actually happening is this, that I will first tell you what the definition of refraction is, and I'll explain it. Refraction as defined as change in speed of wave due to change in medium causing the wave to bend. Okay. Basically, what happens? What happens is this, that the light is traveling from the air to the glass to the water. Okay. Now, when we talk about air, so air is less dense, right? In less dense medium, light travels faster. And this makes sense because think about it, if the medium is less dense, that means that there are less particles in its pathway, right? So the light can travel faster. Now, that light goes from air into glass, or in our example, from air into water. Now, water is more dense. Light travels slower. Remember that. In less dense medium, light travels fast. In more dense medium, light travels slower. Now, what happens that as the speed decreases, the wavelength also decreases. V is equals to F lambda, right? So frequency doesn't change. So when the speed decreases, the wavelength also decreases. So when the wavelength decreases, the light bends. This is what happens in refraction. Okay, that Rehan, V is equals to F lambda. This one, V is equals to F lambda, right? So frequency doesn't change. So velocity decreases. So the wavelength also decreases. Okay. So as a result, because the wavelength decreases, the ray of light will bend. Okay. Now, when the ray of light bends, so this is why the ray of light is bending. Okay. Because when you go from one medium to another, the speed changes. So in less dense medium, the speed is faster. In more dense medium, the speed is slower. So when the speed changes, the wavelength also changes. And that is the reason why the wave will bend. The wave will change direction. Now remember this. If the light travels from less dense medium to more dense medium, so what will happen? That your light bends towards the normal. Okay. what will happen? The light bends towards the normal. So angle decreases. Look at the diagram. Angle of incidence is larger. Angle of refraction is smaller. So as the light goes from less dense to more dense, the light bends towards the normal. I am giving you guys this as a shortcut. If you just learn these points, then when the examiners ask you to make the diagrams, you just look at these points and you make the diagram accordingly. So if the examiners have asked you to make it from less dense to more dense, so draw your ray of light closer to the normal. Okay. And if the examiners are making you go from more dense to less dense, then light bends away from normal. Okay. So then you will draw a larger angle. Let me further elaborate on this by showing you guys or drawing for you guys a ray diagram. Okay, let me make a diagram for you guys and further elaborate on how exactly you will make your ray diagrams. One second. All right. So what I'm going to draw for you guys is I'm going to introduce you guys. This is our, let's say we're going from air into water. Okay. This is our air and this is our water. Okay. Now what we're going to do is that I'm going to show you, this is our ray of light. Okay. What is the first thing you guys are going to do? First thing that anybody is going to do in any question related to reflection, refraction, total internal reflection, doesn't matter. If the examiners give you anything related to this, the first thing every single student over here is going to do is draw a normal. Okay. So this is air and this is our water. So the light is traveling from air to water. Now I'm going to draw a bunch of lines and I'm going to ask you guys if you can identify or if you guys know what they are. Yes, these are your wavefronts, right? Now, what are wavefronts? Does anybody know? Okay. So, okay, first thing that we want to talk about and what exactly is a wavefront. Okay. So I've got some answers over here. A wavefront, basically, if we talk about it, okay, what is it? So a wavefront is either, it represents either the crest or the trough of the wave. That's what a wavefront is. Okay. So a wavefront represents the crest or a trough of a wave. So what basically that means is this, that if you guys are doing this experiment in real life, okay, or you guys are, physicists, and you guys are doing this experiment or any experiment related to waves. Now there's a problem, because every time you want to draw a wave, every time you want to show a wave, you guys will have to draw a bunch of squiggly lines, right? Every time you want to show a wave, you will have to draw a bunch of squiggly lines. And that is obviously something not easily done, right? So to make it easier, the physicists had decided that they will represent the wave in the form of a wave front. Okay. So every single line corresponds to either the crest or the trough. Doesn't matter, one of these. Okay. So it corresponds to the crest of the wave or the trough of the wave. Okay. And everybody will remember this, that the distance between two wave fronts is equal to lambda, wavelength. Okay. The distance between two wave fronts is equal to wavelength. So wherever you guys are drawing your diagram, you guys will make sure that the distance between the wavefronts is the same. Okay. Now, what will happen that air is less dense? Okay. Water is more dense. When we go from less dense to more dense, the speed decreases. When the speed decreases, what happens to the wavelength? The wavelength also decreases. So this is what we will then observe. The wavelength decreases. Okay. So when the wavelength decreases, all of these waves, see the wavelength is decreasing. So now I'm going to draw these waves closer to each other. Okay. Now, if you look at the wave front, see, I've changed it up. My wave fronts are now all closer to each other. Why are they closer to each other? The reason they are closer to each other is because my wave is, what is happening to my wave? My wave is, my wavelength is decreasing. So look, this is why I said that it's important that you know what a wavefront is. Okay. So wavefront represents either the crest or the trough of the wave. The distance between two crest or two trough is your wavelength, right? So the distance between two lines is lambda. So when you're drawing it after refraction, please make sure that you draw the lines closer to each other. Okay. And why are they closer to each other? The reason they're closer to each other is because the wavelength has decreased. And why has the wavelength decreased? The wavelength has decreased because the uh, speed has decreased. And why has the speed decreased? Because we're going from less dense medium to more dense medium. Okay. So this is how you're going to draw your, this is how you're going to basically represent your diagram. Okay. And so you will see a lot of questions on this. This is the reason why I went over this and I wanted to show it to you guys. Okay. So you guys will see past paper questions on this, and this is how you will draw it. So your ray of light is ultimately going to end up where? Your ray of light is ultimately going to end up bending towards the normal, where it will end up going towards the normal. Okay. So this is what your final ray of light is going to look like. So angle of incidence is large, angle of refraction is lesser. So this is what I wanted to go over with you guys. Now, let's go back to what we were discussing. One second. So see, when you are going from air to glass, so you're going from less dense to more dense. So you will show the ray of light towards the normal. See, the angle has decreased. Draw it closer to the normal. And then when you draw it going from glass back into air, you will show it going away from the normal. All right. Now, when we talk about refractive index, the formula for refractive index that you guys have to go ahead and you have to remember is that when you talk about refractive index, so refractive index is the ability of a material to bend a ray of light. Okay. So what is the ability of a material? That it will bend a ray of light. Some materials have greater ability. Some materials will bend the ray of light less. So glass generally has a pretty high refractive index. Water has a lower refractive index. So for this, there are a few formulas that you guys can learn. Okay. One is this one, which is refractive index is equals to speed of light in vacuum. This is fixed. Okay. Speed of light in vacuum or air, they're the same. 3 into 10 raised to the power of 8 meters per second. And divided by speed of light in medium. Okay. So speed of light in vacuum divided by speed of light in medium. This is equals to refractive index. This is another formula that you guys can learn. This is your Snell's law, which is N1. N1 is refractive index. Refractive index of material number 1. Okay, whatever that material is. For example, air and water. So N1 is air. Sine theta 1. Theta 1 is your angle of reflection. Okay, is equals to N2. So N2 would be water and sine theta 2. So whatever the angle is in the water, that is theta 2. So this is your Snell's law. You can go ahead and use this as well. And okay. Now, third thing we have to go over is total internal reflection. To understand what total internal reflection is, once again, I want to share a diagram with you. Just give me a minute. Hold on. Okay, so yes, I wanted to share with you a diagram that will help you understand your total internal reflection much easier. Okay, so now this is our, let's say, glass. Okay, the surface of the glass. Let's always, I've told you guys, whenever we are looking at anything related to waves, we draw the normal. This is the incident light. Okay, now what will happen that we are going, in this particular case, we are going from glass to air. Remember this, total internal reflection only happens when you go from more dense to less dense. Okay? Total internal reflection only happens when you go from more dense medium to less dense medium. So you're going from glass to air. So what is going to happen that as you go from glass to air, so you're going from more dense to less dense. So when you go from more dense to less dense, what will happen? Should my ray of light bend towards the normal or away from the normal? Type out your answers in the chat. Should I draw my line going towards the normal or away from the normal? Yes, everyone who said away is correct. We will draw the ray of light going away from the normal. Okay. So if we are, remember this, if we go from less to more, it goes towards. If we do more to less, it goes away from the normal. Okay. Now, so this is my angle of incidence and this is my angle of refraction. Now, what happens if I keep on increasing the angle of incidence? So as I increase my angle of incidence, my angle of refraction will also increase. Okay, so we are doing this. You guys are sitting with me in the lab and you're like, Miss, what will happen if we increase the angle of incidence? Well, if you increase the angle of incidence, the angle of refraction will also increase. So I say, let's do it. You have the laser light, you have a glass block, let's perform it. So you guys slowly start increasing the angle of incidence. And as you start increasing the angle of incidence, the angle of refraction increases. And eventually, you guys notice one thing. You guys notice that the angle of refraction has increased so much that now the ray of light is literally bending at 90 degrees. Can you guys see that? We increased our angle of refraction, increased our angle of refraction. Sorry, increased our angle of incidence. We kept increasing our angle of incidence and the angle of refraction was also increasing. And then you reached a very certain value at which the light was bending at literally 90 degrees. This is now your critical angle. Okay. So as the angle of incidence increases, the angle of refraction also increases. But if you keep on increasing the angle of incidence, you will eventually reach a value that will cause the ray of light to bend at 90 degrees. This is referred to as critical angle. Critical angle is the minimum angle that causes the minimum angle of incidence, I should add, that causes the ray of light to bend at 90 degrees. The minimum angle of incidence that causes the ray of light to bend at 90 degrees is critical angle. So this is now my critical angle. Okay. What happens if you exceed the critical angle? What happens? So we reach this critical angle and now our light is bending at 90 degrees. Our angle of refraction is coming 90 degrees. So I say to you guys, all right, what if we keep on increasing the angle of incidence? What if we don't stop? What if I increase the angle of incidence even more? Now what will happen? What will happen is this, that instead of the light bending, the light will be reflected back. So instead of the light bending, instead of the light refracting, all of the light will be reflected back into the glass. This is known as total internal reflection. Okay. So total internal reflection is when the critical angle exceeds the when the angle of incidence exceeds the critical angle, the ray of light is reflected back. This is known as total internal reflection. Okay. So critical angle is the angle of incidence that causes the ray of light to bend at 90 degrees. And total internal reflection will happen if we exceed it, if I go on further, right? If I keep on increasing the angle of incidence past the critical angle, I will eventually reach a stage where all of the light, instead of the light refracting, it will just be reflected back. So none of the light will leave the glass. It will all be reflected back into the glass. This only happens when we go from more dense to less dense. Please remember that. So it's not going to happen air to glass. It will happen glass to air. Okay. So it will only happen if you go from if you go from more dense to less dense. All right. That is really important. So this is what your total internal reflection is going to be. Now, when we talk about sound. So sound, first thing, okay. Can you guys please tell me in the chat, what is the difference between a transverse wave and a longitudinal wave? All right, would anybody else like to give their answer? Okay, Zainab is right. Transverse wave, the in transverse wave, the oscillations of the particles are perpendicular to the direction of wave travel. In longitudinal waves, they are parallel to the direction of wave travel. Right, Zainab is right. That is correct. That's the difference between transverse wave and your longitudinal wave. Now, when we talk about so this is again two more formulas that you guys can learn. Okay. Refractive index is equals to sine I over sine R. Okay. This is one formula. So angle of incidence divided by angle of refraction is equal to your refractive index. And this is another formula that you guys can use. N is equals to 1 over sine C. Refractive index is equals to 1 divided by your critical angle. You will find both of these formulas used quite a lot in your past papers. Now, one of the major uses of your total internal reflection is seen in optical fibers. Okay. So in optical fibers, basically, optical fibers are used for a lot of things. Like a lot of your internet cables and all, they use optical fibers. Optical fibers are used for data transfer, right? Optical fibers are also used in medicine. So if anybody over here is really interested in biology and medicine, so a lot of, when you do your medical diagnosis, they use these scopes to look inside the person's body. They often use optical fibers as well. So in optical fiber, what basically happens is this, that your light enters the optical fiber, and when it enters the optical fiber, it hits the glass at an angle that is greater than the critical angle, whatever the critical angle is. Okay. This particular device is designed in this way. This is how they have designed it. So that when the ray of light hits, it hits at an angle that is greater than critical angle. So hence, total internal reflection occurs and the light is reflected back in the glass. Okay. So and this keeps on happening. So the ray of light will again hit a boundary. Again, if it exceeds the critical angle, total internal reflection occurs and the light is reflected back. Right? Same thing will happen. Again, exceeds critical angle, reflected back. And it's designed in such a way that this keeps on happening. So this is one of the applications that you have of total internal reflection, which are your optical fibers. So that's what you have to do for waves. In waves, you guys also have to go over your electromagnetic spectrum. I have not gone over that with you guys over here because obviously we don't have a lot of time available to go over each and everything in detail. But I will tell each and everyone in this class right now, when you're revising for physics, please go over electromagnetic spectrum as well. You guys should know the uses of every single part of the electromagnetic spectrum. So what are ultraviolet used for? What is infrared used for? What are gamma rays used for? Right? Yeah, Zainab, I guess you can say that. If it has a high refractive index, then that is more dense. Um, we will finish after we do thermal physics. This is the last topic that we have for today. So, but yes, electromagnetic spectrum is really, really, really important. Please, everybody, make sure that you go over it. Okay. Learn the uses of each and every component of the electromagnetic spectrum. All right. So coming on to our thermal physics, right? So in thermal physics, everybody over here probably already knows that we have three states of matter: solids, liquids, and gases. Can you please type out in the chat, because this is something that's really basic. I think everybody knows this. Solids, liquids, and gases. So can somebody write down what is the difference in terms of the particles in solids, liquids, and gases? Okay, what else? Yeah, good. Okay, good. Yes, you're right. So in solids, the particles have a fixed arrangement. They are held together by strong forces of attraction, and they can only vibrate in their fixed places. Okay. In liquids, the forces of attraction are weaker. The molecules can move around within the liquid, and and there are more spaces between the molecules. While for gas, the forces of attraction are very weak. The molecules are far apart from each other, and they are free to move, right? Now, when we talk about your topic of thermal physics, so the most important thing in your thermal physics is actually Boyle's law and Charles' law. Okay. So Boyle's law, when we talk about it basically states that volume of a gas is inversely proportional to pressure, provided that temperature remains constant. Quite simply put, pressure and volume are inversely proportional to each other, meaning that if you increase the volume, the pressure will decrease. And if you increase the volume, the pressure will decrease. And if you decrease the volume, the pressure will increase. If you think about it, so imagine that you have a small container, okay? And in that container, you can change the volume of the gas. So if you take the same gas, exact same gas, and put it in a small container, now the number of molecules are the same, right? Because the gas is the same. Number of molecules are the same. But since you have put it in a small container, so now the volume is lesser. So now the same particles are in a lesser volume, so they will do more collisions, right? Remember this. Let me write this down. How is pressure exerted? So what is going to happen that the molecules will collide with the wall of the container. This causes the momentum to change, right? This causes the momentum to change. Now, now you guys should remember from your topic of momentum that force is equal to rate of change of momentum, right? Momentum divided by per unit time. Force is momentum per unit time. So when the momentum changes, what happens? The force exerted on the container increases. Hence, pressure is force per unit area, right? That's the definition of pressure. Pressure is force per unit area. So when the force increases, the pressure also increases. Remember, there are two formulas of pressure that are important. One of them is pressure is equals to force per unit area. And the second one is pressure is equals to rho g h. Okay. So rho is the density of the liquid, g is the gravitational field, and h is the height of the object under the liquid. Okay. So now when we talk about Boyle's law states that when we decrease the volume, the pressure will increase, right? So the particles will be closer together, so they will collide more, so the rate of change of momentum will be greater, so force will be greater. If you increase the volume, so if I take the same gas, but I put it in a large container, so what is going to happen? The force exerted will decrease because there are less collisions. Less collisions, less force, the pressure decreases. This is the formula for it. P1 V1 is equals to P2 V2, which you guys can go ahead and you can learn. Then when we talk about our Boyle's law, we also have something known as Charles' law. Charles' law is the opposite of Boyle's law. Okay. Yes, that's correct. What does Charles' law state? Charles' law basically states that as the temperature increases, the pressure increases. Okay. So Boyle's law is about pressure and volume. Charles' law is about pressure and temperature. Okay. In Boyle's law, pressure and volume are inversely proportional. In Charles' law, pressure and volume are directly proportional. So pressure and temperature are directly proportional, while volume and pressure are inversely proportional to each other. Okay. And Charles' law, the as the temperature increases, the pressure will increase. Boyle's law is about volume. So as the volume increases, the pressure decreases. The formula for Charles Boyle's law is P1 V1 is equals to P2 V2. The formula for Charles' law that you guys can use is P1 upon P2 is equals to T1 upon T2. All right. Then we have to go over our specific heat capacity. What is specific heat capacity? What do you guys think? And does anybody over here, or can somebody please write it out in the chat? What do you think? How can I define specific heat capacity? What do you guys think? How can I define specific heat capacity? Does anybody know? The energy needed to raise the temperature of 1 gram of a substance by 1 degree. Yes, Adam, you are pretty much correct. Basically, the energy you need to raise the temperature of 1 unit mass of any substance by 1 degree, right? So, for example, if I have 1 gram or 1 kilogram, whatever substance, so how much energy do I need to increase the temperature by 1 degree? Okay. That is what your specific heat capacity is. So how much energy do I need to change the temperature or increase the temperature by 1 degrees for 1 kilogram or 1 gram of any substance? Okay. The formula that you guys can use is E is equals to mc delta T. Okay. Where M stands for mass, C stands for specific heat capacity, and delta T stands for change in temperature. Now, another thing that we want to go over in thermal physics is you guys should understand that we have 3 scales that we can use to measure temperature. We have the Kelvin scale, we have the Celsius scale, and we have the Fahrenheit scale. You guys should know how to convert Kelvin into um, Celsius. Okay. Kelvin and Celsius conversions, everybody should have an idea about over here. Okay. So if you want to convert your Celsius into Kelvin, Okay, you will simply add 273.15. Okay, if you want to convert your Celsius into Kelvin, so take your temperature in Celsius, add 273.15, and hence you will get Kelvin. Now, between Celsius scale and Fahrenheit scale, Fahrenheit scale is believed to be, I'm so sorry, between Celsius scale and Kelvin scale. Okay, between Celsius and Kelvin, Kelvin scale is believed to be much better. Does anybody over here know why Kelvin scale is believed to be much better than Celsius scale? Okay, that's not the exact reason though. There is a very important reason why Kelvin scale is better. Not because it has no negative values. That's yes, that's a plus, but yes, well, yes, you are right. It does have something to do with absolute zero. Basically, the Kelvin scale, the temperature is directly proportional to what? To energy of the molecules. Okay? When you use a Kelvin scale, so a Kelvin scale gives you a value that is directly proportional to what? To the kinetic energy of the molecules. Meaning that if the temperature happens to be 0 Kelvin, that means that at that point, the kinetic energy of the molecules is also 0. Okay? So at 0 Kelvin, the energy of the molecules is pretty much as close to 0 as it can be, right? In a Celsius scale, 0 does not mean 0 energy. 0 degrees centigrade does not mean that molecules do not have kinetic energy. They still have kinetic energy, right? But 0 degree Kelvin means that kinetic energy is now 0. Okay. So in Kelvin, the kinetic energy is directly proportional to what? Directly proportional uh, to your energy. While in Celsius scale, it's not directly proportional. It's a linear relationship, but it's not a directly proportional relationship. So when you guys will get the graphs for it, right? Your graphs will come out like this. One second. And you guys will see these graphs in your past papers also. So for a Kelvin scale, right? If the temperature is in Kelvin, so you will get a graph like this, plain and simple. Okay. On the x-axis, I have temperature in Kelvin, and over here I have the energy. Okay. Now, if I draw the same thing, but I draw with degree centigrade. Okay. So my graph will look like this. On the x-axis, I have temperature in degrees centigrade, and over here I have the energy. So my line will actually end up looking something like this. Okay. So you can see when the temperature is 0 degrees centigrade, the energy is not 0. The molecules still have a lot of energy left. The energy will become 0 when we reach the temperature of minus 273 degrees centigrade. Because minus 273 degrees centigrade is equals to 0 Kelvin, right? So these graphs you guys will see commonly in your past papers related to thermal physics. So please go ahead and make sure you cover that. So this is what you have to know related to your thermal physics. Now, what else do you guys need to know? There are some stuff that I do not have the time to go over in this session, okay? But I do want to, before I end anything, before I end this session, I do want to list for you guys those topics, what they are, so you guys cover them, okay? Let me list for you all the important topics that I did not get a time to cover, but you guys, when you're preparing for exams, please, 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 please go over them. Radioactivity. Okay. In radioactivity, everybody should know about alpha, beta, and gamma radiation. Okay, so you guys should know what is alpha radiation. You guys should know that its ionizing ability, its penetrating power. Same for beta, same for gamma. You should know all of your decay equations. Okay, so if it's an alpha particle decay, what will happen? If it's a beta particle decay, what will the equation be? And if it's a gamma particle decay, what will the equation be? Please also go over half-life calculations. Nuclear fission and nuclear fusion. Okay. This is also really important topics that you guys should go ahead and make sure you cover for your physics exam. Along with it, do go over space physics. Okay. So in space physics, you guys should know about the formation of the universe. And most importantly, you guys should know about the Doppler effect and redshift. And the life cycle of the stars. So these are two important things that you guys should go ahead and you can do make sure you cover it before you're preparing for your exams, okay? Because these topics are also really important and you will see them quite a lot in your exams. So does anybody have any questions? Anything that anybody would like to ask? Yes, Rehan, Hertzberg diagram. If you have the time, also go over that. So that when I said life cycle of the stars, right? So in Hertzberg diagram, that's what you're basically going to see. You're going to see, you are going to see your that different stages of the star. Where are they located in the diagram? So your red giants have a specific place. Main sequence stars are going to have a specific place, right? So your white dwarfs, dwarfs are going to have a specific place. So you will need to take a look at that. Kamal, you will have to see your own specification actually. Uh, I don't remember it off the top of my head because there's so many Edexcel. Even in Edexcel, there's so many papers. Some people do combined, some people do double, some people do modular. They have also introduced. So I don't remember what is exactly there in every single paper. So my advice is that you open up your own specification. Students who are doing modular, for example, they might not have to worry about space physics. Yes, Rehan, it depends upon color and temperature. Yeah, astrophysics is in double award, and astrophysics is in the normal IGCSE curriculum as well. They have introduced the modular syllabus as well that's starting from this year. So I think in that one, it's in unit 2, not in unit 1. So depends upon what paper you're giving this year. And it might not, I don't know if it's part of combined. And yes, Rehan, it depends upon the color and temperature. So based on the color and temperature, every single star, that is your red giant, that is your uh, main sequence, it's a white dwarf, it will have a specific position. So what you want to learn is the labeling of that. Okay, the main thing that you have to look is the Hertzberg diagram and just learn the labeling. That where are all the stars located in the diagram. So where are the main sequence, where are the red giants, all of that. So questions are usually just related to that. Okay. Any other questions? Would anybody like to ask anything else? All right. Okay, guys. So we will go ahead and stop it over here for today. I hope this was helpful for you guys. I really hope that you all do really well in your exams. And I hope this was helpful for you guys. And it will hopefully, you guys will score really well on your paper. So I know we didn't have time to cover all the important things, but I hope it did help you out and it made physics at least a little bit easier to revise all the important topics. Yeah, sure. I'll share the presentation, no problem. All right, thank you so much, everyone. I wish best of luck to you for all of your exams. Hope all of you do really, really, really well. And that is it from my side. Have a good day. The recording will be shared on the YouTube. That they will share the link with you. The academy will share the link with you. It's not with me. Okay, everything is with them. They will upload the PowerPoint and they will upload the recording on YouTube. Okay. All right. Best of luck, everyone. I hope you all do really, really well in your exams. Have a good day. Bye, Zainab.